So this was a problem that we tweeted out a request for scenarios. This is one of the ones that came in. I think it was the first one that came in. And this user was asking about, they'd like to be able to analyze raster images using historical radar data from NOAA, which is the U.S. National Oceanic and Atmospheric Administration. And what they want to do is take these freely available rasters, and they wanted to compare these radar images. I'm assuming they're of precipitation. That's the thing we typically use radar for when you see the Doppler on the news. These kind of images with a linear feature of an electric line, and they wanted to see how often does the radar or the precipitation or clouds intersect with the electric line. So this is actually a fairly involved scenario here. There's a lot of different parts to it. First, we have to figure out our intersections, and then we have to figure out through a series of images how often these things are happening. But to break it down, the main thing, I think Dale was going to open up.
Oh, here.
Or we could go to the next slide. Sorry,
yes,
I'm looking.
Right.
So here we have a few different key transformers here, highlighting a few. The main thing is we want to calculate an intersection between, in one case, a vector feature, which is our electric line, and a raster, which is our radar. So we have two things in two different formats. The first thing we got to think is we got to get them in the same format so we can intersect them. Now, my initial thought, I'll admit, was to just go into vector because it's really, easy to think, okay, when does this line intersect this polygon?
So what you would have done there is turn the raster radars into a whole bunch of little squares, I guess, in vector land.
Yes, so you can do that. There is a transformer for that. I believe it's the raster to polygon coercer.
Yes.
However, I was talking with Dimitri here, and Dimitri is an expert at safe and rasters, and his recommendation is always to stay, he's done a lot of performance testing with rasters, and he says always stay in the raster as long as possible, because things will be much faster in the raster land compared to vector. Because
the data volume gets so large. If you're blowing pixels into polygons, you are making a lot of data, and that just takes a computer longer. So somehow try to solve the problem in raster land.
Yep, so with that handy tip from Dimitri, I instead went the other way, and I want to turn my line into a raster, and for that I'm going to use a NumericRasterizer. So that's kind of the star of the show in this workspace. And then, let's just open it up right now.
So let's see, I previously had opened it up. So should I just run it while we're talking and you can walk through things?
Yeah, let's just run it. So I'm starting with, I've got a whole directory. Maybe you can open up, show that directory there and show what our source data looks like.
Click here.
Maybe open it in Finder.
There, okay.
And then we'll just look at one of these images. If you just click on one of those pings here. These are what our data looks like, and we've got this whole series. I think there's 33 of them there of different radar images. That's kind of like what you'd see on the news when they go through, the precipitation. Now this looks really pretty. We know red is probably higher precipitation. However, it's not as useful when we're actually doing analysis. We want to see, with analysis, we really just want to deal with flat number values. So initially in this workspace, I'm doing a few things to just kind of get that raster into shape, so that we can work with it. So the first thing I do is I really want to clarify my no data band. And this is really key when you're working with rasters. There's different formats, different rasters represent basically empty values. So some use something like not a number. There's different things there, and it's important for consistency. I like to just work with 0 because you can multiply things by 0.
The famous -999 for map input people, that was a no data.
Yeah.
But, so you decide to just tell this raster 0.
I like 0 because you can multiply by 0, add by 0. It makes it really great for doing analysis. There's a lot of fun tricks you can use when things are 0. And the other thing I need to do is in order to make that raster look pretty, there's that palette set, so it's red, green, and blue, but that's not really helping us do our analysis. In fact, it's interfering, so I'm just going to take that palette right off because I don't need it to do my analysis. I really just want to figure out how often, we're really just crunching for a number here, how often does that radar intersect this line?
Okay.
So I don't really care about the palette for the purposes. Just get rid of it.
Okay, now you're sorting.
So I'm sorting because I want to make sure I hit these images in order. So I have this whole directory of images, and just to be safe, they have numeric component in there, so I'm just going to sort them to make sure I read them in order.
Right, and just so folks know, the base name is the part of the file name that isn't the extension. And in rasters, that's very important. So it would be this HTTP download, blah, 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 blah.
Yes.
And these numbers came from the website of their original data.
Yes, and they correspond to the actual, they're in order corresponding to the, and these are actually 5 minute 5-minute
And
intervals.
I'll just mention, for rasters, the base name is automatically exposed, but in general, you can always go to the feature type properties and find that under the format attributes here, if you ever need it. So, but it's always there for rasters.
It's always there.
Ready to go. All right, so now you're counting.
So I'm counting, and I use the counter. This is a really handy one anytime you're working with multiple features, just to get a count attribute. Is this the first feature, the 10th feature?
Yes.
I'm going to use this a few times throughout my examples. So that just makes it easier for me. In this case, I want to line up. I want to know which raster it is, because the transformer that's actually doing all the crunching, the raster expression evaluator, needs even pairs of numbers. So I'm going to be grouping by that count number.
Because I see what you're doing here. You are making 2 copies now of the raster. One of them you're setting into the expression evaluator as A. That's your original.
Yeah.
The second copy goes down here, and what is it doing? So
now I'm going to take that second one, and I'm really just using, I don't care about the raster on the second path. I'm just using that to trigger for each raster. I want to read in the power line to get an equivalent pairing of a power line with it. So I've just created a power line in a JSON file. This is just a simple line that intersects with my raster for purposes here. And I'm, in reality, you'd probably have this in a CAD file or something a little more interesting.
Well, I think that there's a popular guy or woman on Twitter, the @shapefile, that would say that 80% of the time it's likely to be a shapefile in here. But in any case, what you're going to do is reread this file over and over again, because it's always the same line.
Yeah.
And then it's just one line that's going to come out of here.
It's going to be one line coming out. The key here is using the 3D forcer. I want to make sure, because when we turn vectors into a raster, the value of the cell value actually comes from the elevation. So in this case, it's not really an elevation, but I just want to set my elevation to 1, because again, you multiply things by 1. It's very handy. So I want all the places there is no power line, all those cells will be 0. All the cells where there is a power line will be 1.
Because the NumericRasterizer is what's going to turn that vector line into a raster, and I see here background value of 0. So that's all the places that isn't the line. So that's
effectively doing the same thing I did in the other no data setter, all in one in this transformer. A few things I had to figure out. I had to inspect my initial rasters. I had to make sure to set my number of cells and rows. So I did those to match up evenly with the other one. And then the last thing I had to do is specify my extents. And if you don't know what the extents of your rasters are, just open them up in Data Inspector. If you click on the feature information window, you'll be able to find all this information. And then you can make sure your vector, the raster you create from your vector feature, exactly lines up with the one you have from your input rasters.
So I'm clicking the little inspector icon there.
So that's my source data here. Yeah. So that would be that might load up all 33, so it might be a little slow.
It might be a bit slow.
It might be a little slow.
I might be asking for trouble.
But
there they are.
There we go.
And so you're saying just drag a box?
Drag a box. You actually want to select the whole raster, not just a cell.
And there we see your 2600 business.
Yeah. So we can tell the extents and the number of cells, and make sure we line up, because that's always.
So these rasters actually didn't know their ground coordinates.
They didn't.
Okay.
So there were files. I just didn't bother. I just took a quick shortcut there. But if you're working with real data, you'd probably want to make sure.
Yeah, you'd have the real coordinates.
Yes, there were files. I was just a little bit lazy and I didn't do that.
So now you got a pair. You got your original, and you got something that is either 0s or 1s. I actually should mention you also turned off anti-aliasing, because that stops you from getting 0.5s and funny things like that.
Yeah, anti-aliasing more makes things look good, but for analysis, you don't really want anti-aliasing. Anti-aliasing is, again, more just make things look pretty, make your lines look pretty. But we don't care about things looking pretty for this. So the real heart of this thing is calculating the intersection, and we're just doing this with the raster expression evaluator. I'm going to show this transformer again. It essentially allows us to just perform any kind of math between either one raster and multiple bands of itself, or 2 rasters. So in this case, I've got 2 different rasters. I've got my raster of my radar data and the raster of the power line, and all I'm going to do is just multiply them. And this is effectively going to give me an intersection, because in any spot where my electric line is 0, the output raster will be 0. So I'll only pick up features where there's both non-zero radar values and electric line. So only those cells will come through. And if there's never any intersection, I'll just get a raster full of 0s. So that's really where everything's happening. Now what I want to do, this is actually a problem. It's not just a one raster problem. This is a time series problem. I want to analyze over multiple rasters, right? So each feature coming out will be its own raster with its own calculated, its own kind of intersection raster. So I want to find out what are the min and max of this raster.
So if the line didn't intersect at all, it'll be 0.
It'll just be 0.
Right.
So the min and max will be 0. If it does intersect, I'll find out what the maximum, the highest value of intersection is.
Yes.
Because if we look at the use case here, they actually wanted to find over a threshold. So it's not just any intersection, it's an intersection over a threshold.
So here you're saying if the max is greater than lucky 13.
I picked 13 just kind of looking at this data. I'm sure someone who actually works with this would have a more meaningful number. But that's kind of what I just came up with for now. It gave me an interesting result. So any radar value above 13, I believe it's out of 255 there.
Yeah.
So now I'm going to just check. Is my min and max over the threshold? So the tester would have done that. The test is pretty simple.
The tester did that.
Just checking.
Check if it's more than 13. Now you picked only 6 of the 33 rasters ended up coming out of that.
Yes. So those are all rasters where I had a positive intersection of the threshold. So these are the ones I care about. These are the ones where I kind of had an intersection occurring or a hit occurring. So what I have to do now is I also want to throw out, it's 2 in a row. If it's the same cloud intersecting in 2 images and it's just the cloud moving over, I don't want to count those as 2 distinct hits because I think the question is how often do they come over, and I'm just going to count those as the same overlap. So I want to throw out scenarios where it's just the same, essentially same cloud. And the way I'm going to do this is by looking ahead. So I know every feature that I'm coming in here is going to be an intersection. So I'm going to look at the count of the last feature to come through here, which may have been many features ago.
Yes.
So I'm going to get the number of the last hit. And that's important because then I'm going to take that number and see how long, hey, what's my number? What was the number of the last hit? That's the number it's been. And these are 5-minute intervals. So I'm going to multiply by 5, and that'll give me my interval in minutes since the last intersection with the cloud.
So this is using this mode and the attribute creator where you can look backwards, forward.
Yes,
I think you were involved in the team that did that work a few years ago.
I was involved. It wasn't me.
Yes.
I think that might have been a little before my time.
Okay.
But yes, this is really the heart of this problem. So this might be something it's easy to ignore. Attribute creator is one of the most commonly used transformers. You may have never expanded that advanced value handling.
Yeah.
But this really is a very powerful feature. It allows you to look ahead and behind from each feature. So we see I'm going feature -1 count. That's saying tell me the count of the feature before.
Yeah.
So and also to optimize it, a little tip. You see I've set it to 1 and 0. The reason for this is for performance. You really only want, if you're only looking one ahead, set it to 1.
Yeah.
Don't read in, because essentially everything ahead we have to store it in memory behind the scenes. So if I put in 50 there, I'd just be storing 50 things I didn't need.
More bookkeeping.
Yeah, so we just want to, it can be handy if you know you're only looking 1 ahead or 2 ahead, just put that number in there.
So at the end of this, for this feature now, I know how many minutes it's been since the last time it touched a cloud, or my line touched a cloud.
So now I know that, and then I'm just going to use another tester to throw out those adjacent ones. So if the interval is less than 5, it means it was just the same cloud from last time. So I'm just going to throw those points out because I'm not going to count those as separate. And then finally, wrapping things up, in order to calculate something meaningful from this, I'm going to figure out the average interval. It wasn't actually specified in the question, but I'm assuming that a common thing you'd want is the average interval between intersections. So StatisticsCalculator allows you to calculate a lot of different types of statistics, the basic ones, min, max, median, even things like standard deviation, mode. But in this case, I'm just going to pick a few of them that I care about. Notice I've actually, if you open it up there, I've actually cleared out, the StatisticsCalculator actually comes pre-populated. Another quick performance tip, or just kind of cleanliness tip, is to delete the ones you don't care about. You'll get less attributes on your features, there's less in memory, and everything's just kind of cleaner. So I like to delete the ones I don't care about. So I'm just going to get my min, max, and mean. And then if we, because we're really just at the end of this, we're just getting one number, a few numbers. So I didn't really bother to write out to anything. I'm just kind of doing this to do a calculation. So I'm just going to log it out and see the values of those attributes, and we'll see our mean is 67.5. So roughly just a little over an hour, we're having
every hour.
Yeah. We're getting an intersection.
We're getting rain.
So it must be.
Is this in Vancouver somewhere?
It must be somewhere quite rainy. Maybe it's Seattle. This is
somewhere in Great Britain, Mark. Oh, he's tuned us out.
Very
Okay.
likely, yes.
Yeah.
Clumsy
Okay,
probably.
so that's one of the more complicated ones.
Yes.
Iris took the hard ones here, and a lot of stuff going on there. If you'll get the recording afterwards, you can play it back in slow motion. But again, the key thing: turn it into a raster problem,
Yes.
and then start working in raster land, and then the adjacent features trick to do the math to figure out how long between interesting events.
Yes.